Okay, in 2.6, we're going to be taking a look at proving geometric relationships. We're still going to do pretty much the same thing we did in 2.5, except this time when we prove things, we're going to try to use a flowchart to kind of help you gather your thoughts, to maybe better understand how we could write our proofs and the order in which you should be writing your statements and reasons. You don't always have to use flowcharts. Rarely will you probably see people using it. Um, and for today, I actually want you to make sure that you continue to use write a two-column proof, as you'll see me do in our lecture. So let's get started right here. Before we get to our flowcharts, let's go ahead and take a look at a few main theorems that we're going to be dealing with. The first one right here is theorem 2.3, right angles congruence theorem. Well, hopefully you know that a right angle is 90 degrees, and therefore all right angles are congruent. There's theorem 2.3. In theorem 2.4, we have the congruent supplements theorem. Remember, if angles are supplementary, they are two angles that add up to 180 degrees. So it says here, if two angles are supplementary to the same angle, or to a congruent angles, they are congruent. So it says that if angles 1 and 2 are supplementary, and angles 3 and 2 are supplementary, and that means that they are both supplementary to angle 2 right there in the diagram, right? They both supplementary to a same angle. Then angles 1 and 2 are supplementary, 3 and 2 are supplementary, and then angles 1 and 3 are supplementary. And if you think about our relationships there, that right there would be which one of our properties that we went over. Give you time to think about it, and hopefully you come up with the answer that it would be your transitive property. Remember, it's similar to that of if A equals B, B equals C, then A also equals to C. And so we see that transitive property right here. Right? 2.5, we have the congruent complements theorem. If two angles are complementary to each other, remember these are two angles that add up to 90 degrees, then they are congruent. So right here in our example, it says if angle 4 and angle 5 are complementary and angle 6 and angle 5 are complementary, then angles 4 and 6 are congruent to each other because they are complementary to the same angle, which happens to be angle 5. Next up, we have our linear pair postulate. Remember, linear pairs are two angles that form a line, which ends up equaling 180 degrees. So it says right here, if angle 1 and angle 2 form a linear pair, angle 1 and angle 2 are supplementary, meaning the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Using angle addition postulate right there to even help us justify what we just showed you in angle 1 plus angle 2 is equal to 180. All right, so don't forget about that property right there. And then finally, the last one is vertical angle congruence theorem, and we should know that vertical angles are congruent. Angles 1 and 3 are vertical angles, so I can go ahead and put little marks right there. And angles 2 and 4 are congruent, and then I'll use 2 arcs to represent that as well. All right, because if I put one arc over 2 and 4, then that will show that angles 1, 2, 3, and 4 are all congruent to each other, which is not true. All right, so let's take a look right here how we could put together our flow chart. Let's start off. I'm moving backwards, and I'm actually going to go ahead and use this exploration page. So we'll go to exploration number 1 right here, and it's match each reason with the correct step in the flow chart. Now, I don't want you just, you know, plugging in letters. From there, I actually want us to think, well, how can you read the flowchart to help us come up with our proof? So right here, I have put together a little 2-column proof. All right. So you can take the time to set that up. And so remember, whenever we do a proof, we should always start off with what is given. So this first part right here, AC is equal to AB plus AB. All right, let's go ahead and the only thing that allows me to say that right there is that the fact of the matter is that is given. So let's put right here, statement 1, AC is equal to AB plus AB. And that is given. All right, so they also have this right here. AB plus BC is equal to AC. So they also put in the beginning. Now, that's not exactly given. It sort of is. So we could actually add that. But since that wasn't the statement there, let's take a look right here. It says AB plus BC is equal to AC. So we can go ahead and put that as another statement here. And I would think that the reason for that would be, remember, we're adding up two segments together. So let's go ahead and put segment addition postulate. That was letter A. So as you can see in the flowchart, remember, sometimes we're going to combine the two statements from the previous and combine that to make our next statement. So in statement 3 right here, they're saying that, look, AB plus AB is equal to AB plus BC. And how we could do that is, well, if I take a look at, let's say what was right here, we take a look at these two statements, and next thing you know, I see both of them, they share AC. So we could either use one of two things. In this one, based off of the given choices, we're going to go ahead and use the transitive property. Or transitive property of equality, we'll go ahead and put transitive POE. Now, some of you may say, well, that could also be substitution. All right, and we've talked about that in 2.5, that we could probably use that as well. But if we can use the transitive property, then let's use that instead. All right, and then finally, they went from statement 4, or statement 3 to statement 4, which now became AB is equal to BC. Well, it looks like something went away, and that would be AB on each side. So how can we eliminate something from both sides? We'll go ahead and put right here, subtraction property of equality. And there you have it. We use the flowchart proof to help you write the actual proof itself. On your homework, when you see a flowchart proof, I also once again want you to make a 2-column proof so that you could gather your ideas and write the proof yourself. All right, let's take a look at the next page and try the next problem out. So once again, we have something similar. They tell us angle 1 is equal to the measure of angle 3. And so let's start off right there with what is given. And we don't have as much space right here, so it might be a little bit small. Oh, what? Can't put given right there. I gotta write down the statement first, which is the measure of angle 1 is equal to the measure of angle 3. All right. So that right there is given. In our second statement, we have the measure of angle EAB, and I look at the diagram, I look at EBA. That is equal to measure of angle 2 plus measure of angle 3. So let's go ahead and write that down. And remember in chapter 1, we went ahead and said if I add two angles together and that equals the whole angle, that is going to be your angle addition postulate. And I'll go ahead and abbreviate that for the sake of our space. All right, next up, take a look at number 3. They're combining the first two statements together, and bam, they end up with measure of angle EAB is equal to the measure of angle 2 plus the measure of angle 1. Now, this one right here, there has been some, when we combine things together, hopefully you realize that we have two options. Typically, it could either be the transitive property, or we could also use the substitution property. Now this one, you cannot use the transitive property. There is no A equals B, B equals C, A equals C. Right here, bottom line is that they took what was once angle 3 and they substituted that in with angle 1. Okay, so by doing that, therefore you can see right here, they plug that in there, and that's where we end up with measure of angle 1. So we'll go ahead and put down substitution property right there for number 3. All right. Next up, we go from there, and then it says measure of angle 1 plus the measure of angle 2. It's still angle EAB. It looks like all they end up doing was they switched the order around a little bit. Okay, and if they switch the order around, hopefully you remember that that is your commutative property. Remember, you could say that 5 plus 3 is still equal to 3 plus 5. So in adding, you have the commutative property. So we'll go ahead and put commutative property of addition. And now you don't have, remember, there is no such thing as commutative property of subtraction. There is a order does matter there. But when it comes to adding, order does not necessarily matter. Let's take a look at number 5. Let me go ahead and put this over here on the right hand side. So next up, we're looking for statement 5, and they have right there the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle CBD. All right, the measure of angle CBD. And so if that's the case right there, and how are they going to come up with that? The measure of angle CBD. So let me look at angle CBD, and I've got angle 1 plus angle 2. So right here, for statement 5, we can go ahead and once again, let's use angle addition. And I went ahead and abbreviated it right there. So for the last thing right here in statement 6, we have the measure of angle EBA is equal to the measure of angle CBD. Okay. Now, it looks like they took two separate things to come up with that. So if I take a look closely at these two statements that I'll circle right there, EBA and measure of angle 1 plus 2 is equal to CBD, they both have the measure of angle 1 and 2 in their statement. When both statements always have the same thing, and then they combine what was left, which was angle EBA and angle CBD, the final thing right here is the transitive property. And there you go for number 6. So once again, make sure that when you guys are doing the flowchart proofs, make sure that you are continuing to use, after you do the flowchart, think how can you come up with your 2-column proof after that. Alright, and then lastly, let's take a look at this right here, the extra practice. Alright, so we start off with what's given, and actually might work out better. Let's see if I can move some of this right here to the side instead. And we'll leave it as is. Hopefully we could put things together. So let's complete the 2-column proof is what it says. Statement 1 should always be given. So we have angle ACB, angle ACD are supplementary, and angle EFG or EGF and angle ACD are supplementary. I'm abbreviating that. Hopefully you guys, once again, make sure you guys type it out, make it look nice and neat. So there we go. So what's missing right here that I could go ahead and put is angle EFG and angle ACD are supplementary. They separated the two things. Oftentimes you could say that statement 1 is one given, statement 2 is the second given, or we could put it all together all in one. Okay, both of that is perfectly fine. So number 2, we have the measure of angle ACB plus the measure of angle ACD is 180. All right, so let's go ahead and then they also included that down below in the second line where it's measure of angle AGF plus the measure of angle ACD is equal to 180. And so if we go ahead and put those together, one of the things that we learned today was the definition of supplementary angles. Okay, because remember, if angles are supplementary, there are two angles that add up to 180, and they both happen to do that right there. In our next part, you can see that, hey, maybe I can go ahead and combine the two together, the two statements to come one, and use right here, remember, when I usually combine two statements to become one, it's either the transitive property, there's a good chance it's the transitive property, or also supplement, or substitution. So right here, we typically want to use transitive when we can. And so the book went ahead and put transitive property of equality. So I'll go ahead and put that down. And if you think about, remember, A equals B, B equals C, then A equals C. What they end up doing is, look, they both have 180. So that would be statement B for both of them. So you got measure of angle ACB plus ACD is equal to measure of angle EGF plus ACD. There's statement 3. Let's go ahead, I'll put this over here on the left hand side or right hand side again. And so we go from there, and then they subtracted. I mean, I look at statement 3 and I see that they both share angle ACD. So that is a good chance right here that I will have to use that subtraction property of equality. And so measure of angle ACB is equal to the measure of angle EGF, and that's right there. And it is the subtraction property of equality. Or you subtract from one side, you must subtract to the other. And then finally, we go from things being equal to congruence. So finally, in statement 5, we have discussed before that if we go from equality to congruence or congruence to equality, it's one simple statement and reason, and the reason right here will end up being definition of congruent angles, especially because we're dealing with angles. If they were segments, then we use definition of congruent segments. Remember, we can use this when an angle or a segment goes from equal to congruence, or vice versa if it's congruent to equal. And you could use that same reason, definition of congruent angles or segments, depending on the scenario that you're using. Okay, so make sure on your homework, guys, you do the flow chart, use it as practice to try to help you organize your thoughts and see if you could put these proofs all together. And finally, after that, make yourself a actual 2-column proof. All right, so you still should be writing 2-column proofs for this assignment. All right, we're done with chapter 2. Test is coming up soon.